Hi, everybody. Today our lesson is going to be on estimating irrational square roots. Remember that when we have a non-perfect square number underneath a radical symbol, when we're taking the square root of a non-perfect square number, we get an irrational number. And therefore, it's important for us to be able to estimate where that number is on the number line so that we can compare it to other real numbers. Where we begin with this, though, is by listing all of the perfect square numbers that we know in order. And you'll see up at the top, I listed those in red: 149, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. I listed the first 15 perfect square numbers. Now that I have them listed, what I'm going to do is I'm going to figure out between which two perfect square numbers is, and let's use this example, between which two perfect square numbers is the number 14. So 14 is between 9 and 16. So the square root of 9 is 3, and the square root of 16 is 4. And what that means is that the square root of 14 is somewhere between 3 and 4. The only question we have left is, well, is it closer to 3 or is it closer to 4? So what we're going to do is we're going to create a number line. And on the number line, we're going to put the square root of 9 and the square root of 16, which we know are 3 and 4. Halfway in between 3 and 4 is 3.5. We need to figure out, is the square root of 14 on the right side of 3.5? So is it between 3.5 and 4? Or is it on the left side of 3.5, somewhere between 3 and 3.5? The question then is, well, is 14 closer to 9 or 16? Is the square root of 14 closer to the square root of 9 or the square root of 16? Well, 14 is 5 units away from 9. 14 is only 2 units away from 16. What that tells me is that 14, or the square root of 14, is closer to 4 than it is to 3. I can make an estimate to the nearest tenths place as to what the square root of 14 is. So we're going to estimate. We can say 3.6, 3.7, 3.8, 3.9. Now it still is 2 units away from 16, so I don't think it's 3.9. But it might be closer to 3.7 or 3.8. So I'm going to say that the square root of 14 is approximately 3.7. And really all I'm concerned with here is that you are on the right side of the half. Okay, so if you said 3.8 or 3.6 or 3.9, that would be perfectly fine as well. We're just getting an estimate here. Now, if I jumped on my calculator and I put in the square root of 14, it's going to give me a long decimal. And I sat here and I did that for you. And it turns out that on the calculator, it says 3.741657386773941. My estimate of 3.7 is actually pretty good. This is the process that we're going to go through in order to estimate irrational square roots. We're going to find between which two perfect square numbers that it falls, and then we're going to figure out which perfect square number it's closer to, and then we're going to make an estimate to the nearest tenth. Let's do a couple again, okay? Let's look at number 1. If we have the square root of 28, between which two perfect square numbers is the square root of 28? So I'm going to start with my number line. 28 is between the square root of 16, which is 4. Oh, actually it's not. It's between the square root of 25, which is 5, and the square root of 36, which is 6. Aha. All right, so halfway between 5 and 6 is 5.5. Is 28 closer to 25, or is it closer to 36? Well, 25 is only 3 units away from 28, and 36 is 8 units away from 28. So somewhere between 5 and 5.5 is the square root of 28. I'm going to estimate 5.3. And as long as you are in that correct half of the half, so as long as you are somewhere between 5 and 5.5, you should have a good estimation. Let's do one more. The square root of 51. So we're doing number 2 here. The square root of 51. We're going to create a number line. And then we're going to figure out between which two perfect square numbers 51 is. 51 is between the square root of 49 and the square root of 64. There's my perfect square numbers. That would be somewhere between 7 and 8. Halfway between 7 and 8 is 7.5. Is 51 closer to 49, or is 51 closer to 64? 51 is closer to 49. So the square root of 51 is going to be somewhere between 7 and 7.5. Maybe we'll approximate it as 7.2. So when we estimate irrational square roots, again, we're going to identify the two perfect square numbers that it's between, and then we're going to decide if it's closer to the lower one or closer to the higher one, and then we're going to estimate it to the nearest tenth. This is the process that you're going to go through to estimate irrational square roots. If you'd like to see more examples, you can open this file up on Schoology and see the rest of them, 3 through 8. If you have any questions, please contact me as soon as possible.